In today's lesson, we will go over how to find the solution of a system of equations. All right, so let's go ahead and get started. Since our objective is to find the system or the solution to a system of equations, that's going to be the guiding principle of our essential question. How can I solve systems of linear equations graphically? How can I determine whether a system of two linear equations has one, infinitely many, or no solutions? All right, those are going to be the two questions that we're going to answer by the time this lesson is done. So let's go ahead and get started. First, let's define what a system of an equation is, and that's simply going to be two or more. There's some typos going on. Two or more equations with the same variable. So if I got two equations and both of them have x and y, that's the system. If I have two equations and both of them have p and q or s and t, any two equations that share the same variables, okay? That's our definition of a system of equations. And when we want to find what a solution is, the solution is going to be to a system of equations. It's going to be any value that makes every equation, makes every equation true. All right, so if we've got 6 different equations, that means our solution needs to make all 6 of those equations true. If we only have 2 different equations, that means that our solution just has to make those 2 equations true. And what we mean by making an equation true is just making sure that when we plug it into that equation, what we get is a factual statement. All right. To check them graphically, we have to see, once we put them in and graph them, we have to make sure if they are solutions, then they need to intersect. Wherever they intersect is going to be where our solutions are, okay? And then to do this part, we got a few steps. So to find a solution to a system of equations, our first step, we're going to put both of these, I'm going to type out these steps in red and make it bold and obvious. Our first step is going to be to type it out into Desmos. All right, Desmos is you guys' best friend. It makes all this stuff super duper easy and simple. Once you type it into Desmos, you're going to find the point of intersection. All right, the point of intersection, that's going to just be where these two lines or more lines cross. You're going to click on that point in Desmos to find the coordinates. Desmos really does most of this for you. And then the point of your intersection is your solution, right? So Desmos makes this thing pretty easy. All right, so let's look at a couple of examples. I'm going to split screen between my notes here and Desmos. I have Desmos up. I'm going to go ahead. Let me make sure this gets over here. All right, now I'm going to go ahead and I like reverse contrast. I'm going to turn that on. I'm going to click projector mode, turn that on, and I like to see my arrows, okay? Make sure you all click projector mode when you use Desmos and the arrows. It helps you make sure you know where your axes are. You don't have to use reverse contrast, but projector mode and the arrows. All right, so now let's do these examples. Example 1 says we want to find the solution, and it says y equals 2x minus 5 and y equals negative 1/3 x plus 9. So my first step is to put both equations into Desmos. So that's what I'm going to do. Y equals 2x minus 5. And then I also have y equals negative 1/3 x plus 9. Oh, what happened? I think my number key was off. 1/3 third. There we go. Y equals negative 1/3 x plus 9. All right, and here we see both of these lines are crossing. Since they are crossing, I'm going to click that point of intersection, and it gives me this ordered pair. Now that I have this ordered pair, 6, 7, I'm going to come back over to my set of notes, and I'm going to type that in. And make sure when you type in your ordered pairs in that you don't forget the parentheses. Without your parentheses, it's just two numbers, and we don't know that it's an ordered pair, okay? So that's example 1. I'm going to do example 2, and I'm going to let you all do the rest of them. All right, example 2 says y equals 3x, y plus 3x equals 10, and y equals x minus 2. What are my solutions, or what is my solution? I'm going to first start off by clearing out the other stuff because we don't need that anymore. And I'm going to type in both of these equations. Y plus 3x equals 10, and y equals x minus 2. Y equals x minus 2. And here we see, let me click back on that. Here we see this is our point of intersection, 3, 1. And now we're just going to type that in as our solution. Once again, don't forget those parentheses, 3, 1. All right. So that's not too hard. I'm pretty sure you all can do the next couple of ones. If you run into trouble or can't figure it out, come back to the Zoom chat, let me know, but we're going to keep on trucking with the rest of the notes. All right, the next thing we have is going to be how to figure out the possible types of solutions, okay? So if you remember our essential question, the second half of that was how to determine whether it's one solution, no solution, or infinitely many solutions. This is going to tell you how to do that. So we have 3 possible types, the ones I just said. We have one solution, and I'm going to try and stick to doing these in their own color. One solution, no solution. I'll make that purple. And infinitely many solutions. All right, and I'll make that one blue. Infinitely many solutions. Okay, now the way we figure this out is based in the way these things intersect. All right, how many times these things cross. Oops, I didn't mean to do that. For one solution, it's going to cross one time. It's only going to have one intersection. For no solution, it's going to cross no times. It's not going to cross at all. And it's going to be no intersection. And if two lines never intersect, that's parallel. That's what we just finished doing. It's going to be parallel, right? And then if we have infinitely many solutions, if we've got one intersection for one solution, no intersections for no solution, and infinitely many, you might think infinitely many intersections, which wouldn't be wrong, but the way we're going to say it's just going to be the same line. All right, they're going to sit right on top of each other. Same line. They overlap. All right. So if we look at a couple of examples in this first one, first example, y equals 2x minus 3, and y equals negative x plus 6. We see that these things intersect right here. This is their graph. They have 1 point in common, all right? Then if we look at the no solution, we see that they don't intersect at all. All right, they have no intersection. And if we look at infinitely many solutions, we see that they sit on top of each other. This line is purple because red and blue make purple. They are all, everything, every point on the line is a solution, okay? It's all interlapping, overlapping, intersecting, overlapping, all right? Then if you want to go through, go look at, I want you all to do this yourself to give you some practice for how to do slopes and whatnot. Go look at the slope and the y-intercept for each of these lines and compare them, compare, contrast, and think about what it is you see. Okay, that'll be an important part. When we look at these examples, to test it, we're going to just type these right into Desmos. Okay. So these examples are asking us to figure out how many solutions there are. To do that, I'm going to split screen with Desmos again. I'm going to type them in. This first one, number 4. I'm going to do number 4, and I want you all to do number 5. Number 4 says y equals 1/2 x minus 5. So I'm going to type that in. Y equals 1/2 x minus 5. I'm going to type that line in, and I'm going to type in 2y minus x equals 4. There we have it, 2 separate lines, and these things do not intersect. When we have lines that don't intersect, that is called no solution, okay? So that's going to be our answer to number 4. Number 4 is going to be, what color is number 4? Purple. That's going to be no solution. No soul. I'm going to abbreviate by saying SOL. No soul, no solution. All right. And now I want you all to try number 5. And if you get stuck in any part of this, come back to the Zoom chat, ask questions, ask for help, and we will get you back on track, okay? Once you finish this, go ahead and get started on the classwork that we have set up in Schoology. And if you have questions on that, let me know, all right?